Hey, what's up? It's your boy Dexter the Tutor. I'm here for another SAT math question. I call this concept complex isolations. As early as elementary school, you've been trained to isolate a variable by using a very simple concept of what you do to one side, you gotta do to the other. It started first with one-step equations where you either add or subtract a number from both sides or multiply or divide, and gradually went to square rooting and squaring to solve. However, on the SAT, you're more than likely going to isolate a variable that will equal other variables. They do so because the majority of algebra, pre-cal, and calculus simply use x and y for Cartesian functions. It's designed to ruffle up your feathers because you don't normally solve a variable that will equal other variables. So let's take a look at the ingredients necessary in order to make this alphabet soup delicious. This question gives you b minus 23 is equal to x over z. The question reads, the given equation relates the positive numbers b, x, and z. Which equation correctly expresses x in terms of b and z? When you see the words correctly expresses, that means you're going to solve for it. Another clue is in the answer choices themselves, since all four options have an isolated x. Now, to solve for what they're asking for, we simply look at what's being done to that variable. Right now, the only thing being done to it is a division of z, so to get rid of it, I'm going to do the opposite by multiplying both sides by z. This will cancel out the z underneath the x. Now, it's very easy to make a mistake when multiplying or dividing both sides to only do it to one of the terms. I like to go all the way and draw the distribution, aka the multiplication arrows, in every term. Z times b is going to give you bz, and z times negative 23 is going to give you negative 23z. What we solve for aligns with answer choice B, which is the answer to this question, but that was easy. A one-step isolation is more than likely going to happen on the first half of the first module. Let's move on to something a little bit more challenging. The equation given is WP is equal to C over 13 distributed into the binomial of 7 plus M. The question reads, the given equation relates the positive variables of W, P, C, and M. Which equation correctly expresses M in terms of W, P, and C? Once again, correctly expresses is telling me what I'm solving for, and we also see the isolated M in all four options. I also want to clarify the second part of that equation, because I do get questions on what does it mean to say in terms of. All that means is that those letters are going to be part of your answer, giving you a heads up that the answer is going to have letters and not a quantitative value. Now, there are multiple ways to solve for this. You can distribute that C over 13 into the binomial of 7 plus M, but that would add an extra step, and visually it looks more complicated. Instead, I'm just going to get rid of the C over 13 by multiplying by its reciprocal of 13 over C. The reciprocal multiplies straight across, giving me 13WP over C. The last step to isolate M would be to subtract 7, isolating M on the right side, and giving me 13WP over C minus 7 on the left, making D the correct answer. Now that we've done a one-step and two-step isolation, let's solve for one that's a little bit trickier, where the variable we're trying to isolate is in a denominator. The equation given in this question reads, 3 over d minus 8 over e is equal to 5. The given equation relates the variables d and e, where d and e are greater than 1. Which equation correctly expresses e in terms of d? Once again, correctly expresses tells me what I'm solving for, and in terms of will tell me what letters are going to be part of the answer. I'm going to subtract 3 over d from both sides to get e on one side. I'm now going to multiply the 5 over 1 by d over d in order to get the two terms on the right side to have the same denominator. This allows me to combine both terms into a single fractional expression. The idea is to have a fraction on both sides of an equation so I can flip them. I'll show you a quick example of why this is legal. 2 over 4 is equal to 1/2. We know that because if you reduce 2 over 4 by 2, you get 1/2. Let's invert both sides to see if it's going to tell the truth. And wouldn't you know it, it does. Even though the values change after inverting it, it's legal to do so because it creates a true statement. So back to the problem, we're literally going to do the same thing. Instead of a negative 8 over e, I'm going to flip it and make it a e over negative 8. And instead of a 5d minus 3 over d, I'm going to flip it and make it a d over 5d minus 3. And now I'm in a very comfortable position to solve for e. The last step is to multiply both sides by -8, giving me E equals a -8d over 5d minus 3. But wait, we don't see that as any of the answer choices. What we're going to do is factor out the -1 from -8 and distribute it into the denominator. A completely legal move. The -1 on top now disappears, leaving you with 8d in the numerator and a -5d plus 3 in the denominator. We still don't see that as any of the answer choices, so I'm going to do one last legal rearrangement with the denominator. I could simply flip them, giving me a final answer of E equals 8d over 3 minus 5d. And just so that way you feel comfortable with what we just did, here's a quick example of the principle in action. 2 minus 3 equals a -1. If I rearrange it to a -3 plus 2, it still equals a -1. So yeah, you can trust me. While we're on the subject of complex isolation, sometimes we can't combine the terms for the variable we're solving for. And in that case, we're going to have to factor it out and divide by a binomial. I call this an old school isolation because I haven't really seen this since 2019, but I don't know what type of dragon College Board is roosting. Better safe than sorry. The question reads, if f over f minus 4p is equal to 3w, solve for f. F is the variable I'm solving for, so I gotta get it out of this denominator. FYI, a numerator cannot distribute into terms of the denominator. If we invert it to f minus 4p divided by f, the division of f can go into the two terms in the numerator. F divided by f would equal 1, and -4p divided by f would just be -4p divided by f. But in this question, the binomial is in the denominator, so we gotta do something different. Instead, I'm just gonna multiply both sides by the denominator of f minus 4p, leaving me with the f on the left side of the equation and a 3wf minus 4p on the right. I'm trying to solve for f, and since it's to the first power, I'm gonna get them all on the left side by subtracting both sides by 3wf, leaving me with f minus 3wf on the left equaling a -4p on the right. Yes, there's an understood coefficient of 1 next to f by itself, but I can't combine them because 1 and -3w are not the same term. So how do I solve for f if it's in two places? What you're gonna do is factor out the f from a binomial, giving me f distributed into the binomial of 1 minus 3w equals -4p. Now that f is in one spot instead of two, I can simply divide both sides by that binomial to isolate it. Don't forget that the negatives in a numerator or denominator can distribute into the other side. And that about does it for complex isolations. If you found this video helpful, like, share, and subscribe, and always remember, not all hard work gets rewarded in life, but there's not a reward worth getting without some hard work. 1.